In this session, we are going to discuss one of the foundation topics from quantitative aptitude, that is number systems. The main aim of testing the numerical ability of a candidate in various competitive exams is to see if the candidate can perform various mathematical operations or calculations. So that is the reason the knowledge of numbers and number systems is very essential for a candidate who wish to appear for various competitive exams. So in this session, we are going to discuss all about the number system and the various types of numbers that we use in all these operations. A number system is a collection of various symbols which are called digits. The number system that we follow is called decimal number system, where the base is 10. The base is 10 indicates that there are 10 different symbols in decimal number system. So let us understand what are these 10 symbols. So the number system that we follow is decimal number system, as I've mentioned, and the 10 symbols that we have here are 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. These 10 symbols are also called as digits. So these are the 10 digits which we use whenever we form a number. Any number that we make is a combination of any of these 10 digits. For example, the number 486 is nothing but a combination of 4, 8 and 6. Similarly, let's say the number is 1486. Now this is a combination of 1, 4, 8 and 6. So whatever numbers that we use in our calculations are all made up of any of these 10 digits. Why? Because we follow the decimal number system. Like decimal number system, there are various other number systems. For example, there is something called as binary number system. A binary number system is a system which has got a base of 2. It has got only two symbols, 0 and 1. So whatever numbers that are made in binary system are only with a combination of zeros and ones. Likewise, the other number system is octal number system, which has got 8 different symbols from 0 to 7. And then there is hexadecimal system, which has got 16 different symbols. Of these, 0 to 9 are the first 10 digits, and then A, B, C, D, E, F are the remaining 6 symbols. Now in all these number systems, the numbers that are made are only of the combination of the digits which are present in that system. So whatever numbers that we make in decimal number system should always be a combination of these 10 digits. We cannot have anything other than these 10 digits. Now, as I have already mentioned, the base of decimal number system is 10 because we use 10 different symbols here. So this number 1486 can be represented as 1000 plus 400 plus 80 plus 6. The reason behind this kind of representation is because we are using different digits, that is 1, 4, 8 and 6, and each of these digits has got a place value depending on its position. For example, 6 here is in units place. This is called as units place. Then 8 is in tens place, 4 is in hundreds place, and 1 is in thousands place, and so on. That means the first position from right hand side is units place. It is referred as units place or ones place. That means its positional value is 1. The second position is referred as tens place. That means whatever digit is present there has to be multiplied with 10. The third one here is hundreds place. So whatever digit is present in hundreds place has to be multiplied with 100. Why? Because its positional value or digits value is 100. And similarly, 1 is in thousands place. So that is the reason the correct way of taking the number here would be 1000 plus 400 plus 80 plus 6. That is nothing but 1 into 1000 plus 4 into 100 plus 8 into 10 plus 6 into 1. That means we have 6 in units place, 8 in tens place, 4 in hundreds place and 1 in thousands place. So this is how a number is represented in decimal number system. For example, let's say the number is 24. 24 should be taken as 2 into 10 plus 4 into 1. Why? Because we have 4 in units place and 2 in tens place. So the basic representation of a number in decimal number system has to be done with the place value as 10 power 0, 10 power 1, 10 power 2 and 10 power 3 and so on. 10 power 0 is nothing but 1. So that is why it is called as units place. 10 power 1 is 10. 10 power 2 is 100. 10 power 3 is 1000 and so on. So from this we can understand that the representation of any number in decimal number system should be in terms of powers of 10, starting from 0 from right hand side to left hand side. So any two-digit number AB can always be represented as 10A plus B. Why? Because it is A in tens place, so it should be multiplied with 10, and B in its units place, so that is multiplied with 1. So a two-digit number AB should always be represented as 10A plus B. Similarly, a three-digit number ABC should be taken as 100A plus 10B plus C. So this is how we represent the numbers in case of decimal number system. And since bank exams test about only the knowledge of decimal number systems, we are going to restrict our discussion only up to this number system. And we shall not discuss about various systems like binary number system and octal number system and so on. So the most important point to be understood here is the representation of numbers in case of decimal number system. Let us now understand how the numbers in case of decimal number system can be classified. The point here is we have got only 10 digits, but the numbers that are there in decimal number system are infinite, and all these infinite numbers are made up of a combination of these 10 digits, as I've already mentioned. Let us now understand what is meant by real numbers and the classification of these real numbers. These are the numbers which represent the actual physical quantities like height, weight, density, etc. in a meaningful figure or a meaningful number. Now these are basically classified as rational numbers and irrational numbers. So real numbers are those numbers which we use in the physical world to measure various things like height, weight, etc. So this comes out as a meaningful figure or a meaningful number, and the basic classification of real numbers is rational numbers and irrational numbers. Now rational numbers are those numbers which can be represented in the form of A by B. As you can see here, these are the numbers which can be represented in the form of A by B, where A and B are integers and B should not be equal to 0. So as we can understand from this definition, rational numbers can be expressed in the form of a fraction, that is A by B, where the denominator B should not be equal to 0 and A and B have to be integers. Now some examples of rational numbers here are 1 by 2, 3 by 4, 7 by 12. As you can see, these are all in the form of A by B. And at the same time, we can also have negative fractions. That doesn't make a difference. So 1 by 2, 3 by 4, or minus 3 by 4, minus 7 by 12, or minus 1 by 2. All these are examples of rational numbers. Similarly, 8 again is also a rational number. Why? Because 8 can be taken as 8 by 1. Similarly, minus 6 can also be taken as minus 6 by 1. So from this we can understand that all the integers are also rational numbers. Why? Because all integers are like fractions where the denominator is 1. So we can say that even integers are rational numbers. And likewise we have 1 by 3, 1 by 7, 2 by 9, etc. These are all the examples of rational numbers. Next comes irrational numbers. Irrational numbers are those numbers which cannot be expressed in the form of A by B, where B is not equal to 0. So we can say that numbers which are not rational are irrational. So as you can see here, these are the numbers that are not rational in nature and cannot be expressed as A by B, where B is not 0. So all those numbers which cannot be taken in the form of fractions should be considered as irrational numbers. And some examples here are root 2, root 3, pi, etc. Right? So from this we can understand that all the square roots of imperfect squares comes under irrational numbers. For example, root 5, root 7, root 8, all these form a part of irrational numbers. Let us understand what is the actual difference between rational and irrational numbers with the help of these examples. Now if you try to look at these fractions, 1 by 2 can be taken as 0.5, or minus 1 by 2 can be taken as minus 0.5. Similarly, 3 by 4 or minus 3 by 4 is minus 0.75. Likewise, minus 7 by 12 can be taken as minus 0.58333, so on up to infinity. Then 8 by 1 is nothing but 8.0, minus 6 by 1 is minus 6, 1 by 3 we know is equal to 0.333, so on up to infinity. And 1 by 7 would be 0.142857 and 142857 and so on. And likewise 2 by 9 here would be equal to 0.222 up to infinity. So from all these examples, after converting them into decimal part, you can understand that all the rational numbers are either terminating or non-terminating. That means if you look at 0.5, it is a terminating number. The numbers after the decimal ends at some point. Similarly here again, the numbers after the decimal point ends at some particular point. And in case of 8.0, minus 6.0, the numbers end after the decimal point. So these are referred as terminating numbers. And the other numbers are referred as non-terminating numbers. That means after the decimal point, the number never ends. It goes up to infinity, as in the case of 0.58333 up to infinity, or 0.33, or 0.22, or like 1 by 7, 0.142857. So these numbers never end. They go up to infinity. So these are referred as non-terminating numbers. So every rational number is either terminating, like in this case, or non-terminating, as we can see here. Now in this non-terminating numbers, we find that there is some part of the number which appears at regular intervals. It occurs again and again. For example, if you look at 0.333, here this is nothing but 0.3 bar. That means this digit 3 or this number 3 occurs again and again at regular intervals up to infinity. Similarly, in case of 0.22, it can be taken as 0.2 bar. Why? Because here the number 2 occurs again and again at regular intervals. And if you look at 0.58333, up to 5,8 it is fine, but after 8 the number 3 goes on up to infinity. So this can be taken as 0.583 bar. That means 3 again occurs again and again at regular intervals. And in this case we find that 142857, the set of these 6 digits, occurs again and again up to infinity. As you can see, this is 0.142857, 142857, and 142857, so on. So the point to be observed here is, as we have discussed, rational numbers are either terminating or non-terminating, but in case of all these non-terminating numbers, we find that a particular set of numbers occurs again and again, or they reoccur, or we can say these are recurring numbers. That means they occur again and again at regular intervals up to infinity. So very clearly, rational numbers are either terminating or recurring. Why? Because all these non-terminating numbers are recurring in nature. So that's the basic idea about rational numbers. These rational numbers either terminate at some point, or if they are non-terminating, they recur in nature. That means they are recurring numbers. Let us now understand the basic idea behind irrational numbers. Now, as we have seen, the examples are root 2, root 3, pi, etc. Now, if you look at root 2, the approximate value of root 2 is 1.414. Similarly, the approximate value of root 3 is equal to 1.732. That means, in case of irrational numbers, we never get an exact answer. We can always talk about an approximate answer in terms of decimal or fractions. The point to be observed here is root 2 or root 3 here. That means irrational numbers are non-terminating in nature. That means these numbers after the decimal point goes up to infinity. And at the same time, they are non-recurring in nature. That means there is no particular digit or no particular set of numbers which occurs again and again at regular intervals. So the numbers which are non-terminating and non-recurring are called as irrational numbers. So that is the basic difference between rational and irrational numbers. Rational numbers are either terminating or recurring. So we can understand that rational numbers are either terminating or recurring in nature, whereas irrational numbers are non-terminating and non-recurring. Non-terminating and non-recurring. That means they neither terminate nor do they recur. So such numbers are referred as irrational numbers. Let us now look at the classification of numbers into various types. The first one here is natural numbers. Natural numbers are those numbers which are used for the purpose of counting. It is a set of positive counting numbers and denoted by the letter n. As you can see here, natural numbers include 1, 2, 3, 4, 5 and so on up to infinity. The next one here is whole numbers. Whole numbers is a set of all the natural numbers including 0. It is generally denoted by the letter W, and as you can see, the set here consists of 0, 1, 2, 3 and so on up to infinity. The next one comes here as integers. Integers is a set of all whole numbers along with the negative numbers. As you can see, in the previous two cases, we did not have any negative number. All the numbers were positive. But now, integers also include negative numbers along with the whole numbers. Generally denoted by the letter I, this set consists of the numbers starting from negative of infinity and then coming up like -3, -2, -1, 0, and then positive integers 1, 2, 3 and so on up to infinity. So as you can see, it is a set which has got all the whole numbers along with the negative numbers. So all such numbers are referred as integers. Then the next classification here is even numbers and odd numbers. Even numbers, as we know, are those numbers which are exactly divisible by 2. This is a set of numbers that is exactly divisible by 2, or we can say these are the exact multiples of 2. So 2, 4, 6, 8 and so on are the examples of even numbers. Why? Because these are the numbers that are exactly divisible by 2. The next one is odd numbers. Odd numbers are those numbers which are not exactly divisible by 2. So set of numbers which are not exactly divisible by 2 is referred as odd numbers, or we can say numbers which are not even are odd. So 1, 3, 5, 7 and so on are the examples of odd numbers, as all these numbers are not the exact multiples of 2, or these numbers are not divisible by 2. So if a number is divisible by 2, it can be taken as even, otherwise it is to be considered as an odd number. Let us now understand what is meant by factors and multiples. If a number x divides y perfectly, then x is considered as a factor of y and y becomes the multiple of x. So as given here, when a number x divides some other number y perfectly, what does it mean by perfect division? A perfect division is the one where the remainder is 0. So in such cases, the number x is referred as a factor of the number y, and y is called the multiple of x. For example, 4 is a factor of 16. Why? Because 4 can divide 16 exactly. 16 by 4 is equal to 4. The remainder is 0. So that is the reason 4 is considered to be a factor of 16. And hence 16 becomes a multiple of 4. Why? Because if x is a factor of y, y has to be the multiple of x. Similarly, 18 is a multiple of 16. Why? Because 18 is divisible by 6 exactly. So if 18 is divisible by 6, that means 6 is able to divide 18. So if 18 is multiple of 6, we can say that 6 is a factor of 18. So very clearly factors and multiples are linked to each other. If A is a factor of B, then B has to be a multiple of A. So if 4 is a factor of 16, 16 is a multiple of 4. Apart from 4, the other factors of 16 are 1, 2 and 8. Why? Because 16 is exactly divisible by all the three numbers. 16 by 1 is equal to 16, 16 by 2 is equal to 8, 16 by 8 is equal to 2. So only those numbers which can exactly divide the given number should be taken as the factors of the number. And similarly, only those numbers which are exactly divisible by the given number should be considered as multiples of the number. For example, apart from 18, the other multiples of 6 are 6, 12, 24, 30 and so on. Why? Because all these numbers are divisible by 6. So factors are those numbers which can exactly divide the given number, and multiples are those numbers which are exactly divisible by the given number. Based on the number of factors, all the natural numbers except one can be classified as either a prime number or a composite number. So let us understand this important differentiation between prime numbers and composite numbers. Prime numbers, these numbers have no factors besides 1 and itself. So prime numbers are those numbers which have only two factors, 1 and the number itself. And some examples of prime numbers are 2, 3, 5, 7, 11 and so on. So all these are the numbers which have only two factors, 1 and the number itself. For example, the factors of 2 are 1 and 2. Factors of 3 are 1 and 3. For 5, 1 and 5. For 7, 1 and 7. These numbers are divisible only by 1 and by the number itself. No other number can exactly divide such numbers. So these numbers are called as prime numbers. Next comes composite numbers. Composite numbers are the numbers that have other factors beside 1 and itself. So the numbers which have more than two factors are called composite numbers. For example, 4, 6, 8, 9, 10, 12. So we can say that all the numbers other than prime numbers can be taken as composite numbers. For example, 4, the number of factors of 4 are 1, 2 and 4. So we can see that there are more than two factors. Apart from 1 and the number itself, 2 is also a factor of 4. Why? Because 2 can divide 4 exactly. So 4 cannot be a prime number as it has more than two factors. So it is called a composite number. Similarly, when you look out for all the other numbers, they have more than two factors. The factors of 6 are 1, 2, 3 and 6. For 8 we have 1, 2, 4 and 8. For 9 we have 1, 3, 9 and so on. So all these numbers have got more than two factors. So they are called as composite numbers. One important point to be observed here is the number 1 is an exception. It is neither a prime nor a composite number. 1 does not participate in any of these two categories. So except 1, all the remaining natural numbers can be classified either as prime numbers or composite numbers depending on the number of factors which they have. Let us now learn what is meant by a fraction and what are the various types of fractions. As we have already discussed, rational numbers are those numbers which can be expressed in the form of a by b, where b is not equal to 0 and a and b both are integers. And from the various examples, we have found that there are some rational numbers where the denominator b is equal to 1. For example, 8 is a rational number. Why? Because it is in the form of 8 by 1, where the denominator b is equal to 1. And then at the same time, there are some other rational numbers where the denominator b is not equal to 1. So this is one major classification of rational numbers. Rational numbers can either be integers or fractions depending on the denominator. If the denominator is equal to 1, then it is an integer. And if the denominator is other than 1 but not equal to 0, then it is considered to be a fraction. So fractions are nothing but rational numbers where the denominator b is not equal to 1. Whereas integers are rational numbers where the denominator b is equal to 1. So let us now understand what is actually meant by fraction and what are the various types of fractions. A fraction denotes a part or parts of a unit. So a fraction is nothing but some part of the given unit. It is majorly classified into the following types. So here we have got three major types of fractions: proper fractions, improper fractions and mixed fractions. So let us understand what is the difference between these three types. Proper fractions. These are the fractions in which the numerator is less than the denominator. For example, 1 by 2, 3 by 5, 6 by 7, 9 by 13 and so on. So as you can see here, in each of these fractions, the numerator, that is a, is less than the denominator, that is b. For example, 1 is less than 2 or 9 is less than 13. So all these fractions are called proper fractions. Why? Because these are actually a part of 1, that is 1 unit. So these fractions are called proper fractions. And the other point that we can understand here is proper fractions are always less than 1. Why? Because these are a part of 1. The second type of fraction that we have here is improper fractions. Now these are the fractions where the numerator is more than the denominator. That means a, the numerator, is more than the denominator b. Now some examples here are 5 by 4, 3 by 2, 14 by 9, etc. So as you can see, in each of these fractions, numerator is more than the denominator. 5 is more than 4, 14 is more than 9, 3 is more than 2. So all such fractions where the numerator is more than denominator are called improper fractions. Why? Because they are in the form of a by b, but they are more than 1. So such fractions are improper fractions. And the point that to be understood here is all these fractions are greater than 1. So proper fractions are those fractions where the value is numerically less than 1, and improper fractions are those where the value is more than 1. The third and the last fraction here we have is mixed fractions. Now mixed fractions are those fractions which consist of two parts, an integral part and a fractional part. So a mixed fraction is a combination of an integer as well as a fraction. Some examples here are 1 6 by 7, 12 5 by 8, 9 2 by 7, etc. So as you can see here, each of these fractions have got two parts, an integer part and a fraction part. For example, in the first case here, we have 1 6 by 7. So 1 is the integer part and 6 by 7 is the fractional part. Similarly, 12 5 by 8. Here 12 is the integer part and 5 by 8 is the fraction part. And likewise in 9 2 by 7, 9 is the integer part and 2 by 7 is the fraction part. One important point that is to be observed here is a mixed fraction is nothing but an improper fraction. Why? Because when we simplify this, it comes out to be more than 1. As already we have some integer part, that is 12, 9, 1, etc. So when this complete fraction is considered, that is integer part plus the fraction part, it will definitely be more than 1. And we very well know that fractions which are more than 1 are improper fractions. So all the mixed fractions are actually improper fractions. So this is the major classification when it comes to fractions: proper fractions which are less than 1, improper fractions which are more than 1, and mixed fractions which have got a combination of an integer part and a fraction part. Let us now take the first module from this topic of number systems, where we are going to discuss questions related to interchanging of digits of the given number. But before we take an example, let us understand how to represent numbers in case of decimal number system. As we have already learned, we follow decimal number system where the base is 10. That means there are 10 different symbols from 0 to 9. So whatever numbers we use are made up of a combination of any of these 10 symbols or 10 digits. Let us understand how to represent a number in case of this decimal number system. For example, any two-digit number AB should always be taken as 10 into A plus B. Why? Because this is referred as units place and this is referred as tens place. That means whatever digit is there in place of B should be multiplied with 1, and whatever digit is there in place of A has to be multiplied with 10. So that is the reason we take it as 10 into A plus B into 1. So this can be taken as 10A plus B. Similarly, if there is a three-digit number ABC, that three-digit number ABC should be taken as 100A plus 10B plus C. Why? Because this is referred as units place, tens place and hundreds place respectively. So whatever digit is present in place of C should be multiplied with 1. So C into 1 is C, plus this B has to be multiplied with 10. Why? Because it is in tens place. The place value is 10. So multiplied with 10 plus the digit in place of A or in hundreds place has to be multiplied with 100. Why? Because the place value is 100. Likewise, if there is a four-digit number, it can be taken as 1000A plus 100B plus 10C plus D and so on. So remember that any two-digit number AB should always be taken as 10A plus B, and three-digit number should be taken as 100A plus 10B plus C. So with the help of this point, let us see how can we solve the questions related to interchanging of digits of the given number. Let us now take an example from model 1. The given question here is the number obtained by interchanging the two digits of a two-digit number is more than the original number by 27. If the sum of the two digits is 13, then what is the original number? So as given in the question, the number obtained by interchanging the two digits of a two-digit number should be more than the original number by 27, and the sum of the digits must be 13. And from these two conditions, we need to find out what is the original number. Let us assume that the original two-digit number is equal to AB. The original number, which is of two digits, is equal to AB, where B is the units place and A is the tens place. And as we have already learned, any two-digit number AB stands for 10 into A plus B. Since B is the units place and A is the tens place, they have to be multiplied with 1 and 10 respectively. So this is the original number, that is 10A plus B. Now the number that is obtained by interchanging the two digits of this two-digit number is more than the original number by 27. So let us now understand what would be the number that is obtained by interchanging the two digits. That means the interchanged number. Let us see what will be the interchanged number. Now we know that by interchanging the two digits AB, the number obtained would be BA. Why? Because if we interchange the digits, B goes in tens place and A comes to units place. So the number that we have would be BA. And this two-digit number BA should be taken as 10B plus A. Why? Because now we have A in units place, so multiplied with 1, and B in tens place, so it is multiplied with 10. Now as given in the question, the number obtained by interchanging the two digits, that means BA is more than the original number by 27. That means interchange number is equal to original number plus 27, as it is more than the original number by 27. So we can say that BA should be equal to AB plus 27. But in calculations, we should take the number BA as 10B plus A, and the number AB should be taken as 10A plus B. So let us substitute BA as 10B plus A, which is equal to AB, that is 10A plus B plus 27. Now by taking 10A plus B to the other side, we get 10B minus B is 9B, and A minus 10A is 9A, equals to 27. So if we take 9 common, we get B minus A is equal to 27 by 9, that is 3. So now we know that the difference of the two digits B minus A is equal to 3. And the next statement here is, if the sum of the two digits is 13, what is the original number? So we also know that the sum of the two digits are A and B. So sum of the two digits A plus B is equal to 13 as given in the second statement. So now we know what is the difference of the two digits as well as the sum of the two digits. That means we have two equations and two variables A and B. That is, the second equation here is B minus A equals to 3. So two equations with two variables. And by solving these two equations, we can find out what is the value of A and B. So let us try to add both the equations. If we add the equations, A and minus A gets cancelled, B plus B would be 2B. And 2B equals to 13 plus 3, that is 16. So if 2B is 16, very clearly B should be equal to 8. So we know that the digit B is equal to 8. And now by taking B in any one of the equations, we can find out the value of A. So let us substitute B equals to 8 in the first equation. So A plus 8 is 13. A plus 8 is equal to 13. That means very clearly A is equal to 5. So now we know what is the second digit A, that is equal to 5. The question here is, what is the original number? We know that the original number is AB. So as A is 5 and B is 8, we can say that the number AB, that is the original number, should be 5, 8, 58. So option 4, 58 has to be the correct answer. But friends, this is the normal way or the general way of solving the question with the help of two equations and two variables. But this question can be answered in a smart way without writing any of these steps. So let us now understand how to get the answer for this question directly by using the options. If you try to look at the question here, we have got two conditions. One condition is that the sum of the digits is 13, and the other condition is that the number obtained by interchanging the original number is more than the original number by 27. So let us just verify which of the given options satisfies both the conditions. We will first try to check the condition, that is sum of the two digits is 13. Why? Because this is easy to verify. So let's now check which option has got sum of the digits as 13. If you look at option number 1, 63 is the number. Now 6 plus 3, that is the sum of the digits, is 9. But since we want the sum of the digits to be 13, option 1 cannot be the answer. Similarly, if you look at option 2, 7 plus 4 is 11, which is not equal to 13. So even option 2 gets cancelled. Moving to option 3, the sum of the digits 8 plus 5 is equal to 13. So this may be the possible answer as one of the conditions is satisfied. And similarly in option 4, the sum of the digits 5 plus 8 is 13. So either option 3 or option 4 may be the answer. Let us now see which of these options satisfy the first condition. That is, if we interchange the two digits, the number obtained should be more than the original number by 27. Now, if this number 85 is interchanged, we get 58. And 58 is less than 85. But the question clearly says that the number obtained by interchanging should be more. Now, since the number obtained by interchanging the digits is less, it can no way be the correct answer. So even option 3 gets cancelled. So let us now check the fourth option for the second condition. That is, the number obtained by interchanging the digits should be more than the original number by 27. Now here in case of 58, when we interchange the two digits, it becomes 85. And 85 is more than 58 by 27. Since the difference between these two numbers is 27. 85 minus 58 is exactly 27. So as you can see here, option 4 satisfies both the conditions. That is, the sum of the digits is 13 and the number obtained by interchanging the digits is 27 more than the original number 58. So since it satisfies both the conditions, it can directly be taken as the correct answer. So this is how we can avoid writing all these steps and directly get the answer by eliminating the wrong options. So simply try to go by the options and find out what is the correct answer. But friends, at the same time, you also need to understand the procedure, that is the normal way of solving the question, as it may be useful in some of the questions. Let us now take the second example from model 1, which is based on the interchanging of two digits of the given number. The question here is, when the digits of a two-digit number are interchanged, the number obtained is less than the original number by 36. What is the original number if the difference between the two digits is 4? So as you can see, this example here is quite similar to that we have discussed in example 1. And we know that the best way to solve these questions would be to go by options rather than writing all the steps. So let us try to understand what are the two conditions given and check which of these options satisfies both the conditions. Now the first statement here is when the digits are interchanged, the number that we obtain is less than the original number by 36. So if we say that the original number is AB, then the interchange number would be BA, and as given in the question, the interchange number is less than the original number by 36. So we can say that BA should be AB minus 36, as it is less than the original number by 36. And also we know that the difference between the two digits is 4. So the difference between the two digits, that is A and B, the difference should be equal to 4. So whichever option satisfies these two conditions has to be the correct answer. Let us first check for these conditions in option 1. The number here is 84. Now if we try to understand the difference of the digits, we know that it should be 4. And here 8 difference 4 is equal to 4, or 8 minus 4 is equal to 4. So very clearly option 1 satisfies the first condition. Let us now go for the second condition in option number 1. The second condition here is BA equals to AB minus 36. That means interchange number should be less than the original number by 36. So if we interchange the two digits, what we get here is 48. 84 becomes 48. And 48 is equal to 84 minus 36. 84 minus 36 is equal to 48. So very clearly even the second condition is satisfied. That is, the reverse number is original number minus 36. So option number 1 satisfies both the conditions. So it has to be the correct answer. But friends, before we mark option number 1 as the answer, let us verify even the remaining options. Why? Because there is a twist in the question. And if we mark option number 1 as the answer, we will go wrong. Let us see what happens in the remaining options. Now if you look at option number 2, that is 51, here again the difference between the two digits, 5 difference 1, or 5 minus 1 is equal to 4, as given in condition number 2. So option 2 satisfies one of the conditions. Let us see whether it satisfies the second condition or not. So if we interchange the digits, 51 becomes 15, and 15 is again 36 less than 51. Why? Because 51 minus 36 is equal to 15. So even option 2 satisfies the second condition, that is BA is AB minus 36. So option 2 as well can be the correct answer. And similarly, if you look at option 3, the difference between the two digits is 4. 7 minus 3 is equal to 4, and the interchange number is 37. And 37 is nothing but 73 minus 36. So option 3 also satisfies both the conditions. So this is the twist in the given question. There is more than one answer or more than one number which can satisfy both the given conditions. And hence we cannot mark option 1 as the answer since it has satisfied both the conditions. Why? Because we are not able to zero in into the correct answer, or we are not able to decide what exactly is the number which the question is talking about, as the given conditions are satisfied in more than one case. So hence the answer here has to be cannot be determined, that is option number 4. So remember, there may be certain cases where we will not be able to decide what exactly the number is for the given conditions. So in such cases answer has to be cannot be determined. Now before we move on to the next question, let us understand why the answer here cannot be determined, or what is the difference in this question when compared to the previous question. Now to understand that, we need to go in a step-by-step procedure. So let us go by the step-by-step procedure and check what happens here. Now the original number AB can be taken as 10A plus B, and the reverse number should be taken as 10B plus A, as discussed earlier. We know that BA equals to AB minus 36 as given in one of the conditions. So let us check what happens in this case. BA is nothing but 10B plus A, and this should be equal to the original number AB, that is 10A plus B minus 36. Now if we try to simplify this equation, we find that 10B minus B, that is 9B, and A minus 10A, that minus 9A equals to minus 36. Or we can say B minus A equals to minus 4. If 9 is taken common, 36 by 9 will be equal to 4. Or to simplify this, we can say A minus B is equal to 4. So as per the first condition, the equation that we get is A minus B is equal to 4, and the second condition says A difference B is equal to 4. So these are the two equations which are framed with the help of the given conditions. Now if you try to observe the two equations, that is a minus b equals to 4 and a difference b equals to 4, we realize that these are actually the same equations. There is no difference between the first equation and the second equation. That means we have only one equation with two variables, and it is impossible to solve for two unknowns with the help of only one equation. So that is the reason answer cannot be determined. Why? Because there can be many numbers which satisfy a minus b equal to 4 or a difference b equals to 4. Let us now take the second model from this topic of number systems, which is based on the concept of consecutive numbers. Consecutive numbers are those numbers which come one after the other at regular intervals. Now we have various types of consecutive numbers. Let us first understand these and then we shall take up some examples based on them. The first one here is consecutive natural numbers. So these are those natural numbers which come one after the other. And these can be represented as x, x plus 1, x plus 2, x plus 3 and so on. That means if the first number is x, then the second consecutive number or the second consecutive natural number would be x plus 1, then x plus 2, x plus 3, x plus 4 and so on. For example, 1, 2, 3, 4. These are consecutive natural numbers. Why? Because we find that these are all in a row, 1, 2, 3 and 4 without any gap. So these are called as consecutive natural numbers, or they can be called as successive numbers. Similarly, 83, 84, 85, 86, even these are consecutive natural numbers or successive numbers. And if you can see here, if the first number is taken as x, that means if 83 is x, then x plus 1 is 83 plus 1, 84, x plus 2 will be 83 plus 2, 85, x plus 3 will be 83 plus 3, 86 and so on. So whenever we solve questions related to consecutive numbers, we should take the first number as x, then the second number be x plus 1, third number is x plus 2 and so on, depending on the number of consecutive numbers that we have. The second one here is consecutive even numbers. Now we have already understood what are even numbers. Even numbers are those numbers which are exactly divisible by 2 or which are exact multiples of 2. So whenever we have even numbers in a row without any gap, then such numbers are called consecutive even numbers. For example, 2, 4, 6, 8. All these are consecutive even numbers. And these even numbers can be represented as x, x plus 2, x plus 4, x plus 6 and so on. That means if the first number is x, then the next number should be x plus 2. The third one has to be x plus 4. Fourth one will be x plus 6 and so on. And remember, the first number x has to be even. So if we take any even number in place of x, then following x plus 2, x plus 4, x plus 6 will give us consecutive even numbers. For example, 68, 70, 72 and so on. If the first number x is 68, then 68 plus 2, 70 will be the next even number. 68 plus 4, 72 will be the third even number and so on. So the point to be observed here is in between two consecutive even numbers, the difference is always 2. Plus 2 will give the next one. Again plus 2 to this will give the next one. Again plus 2 gives the third one and so on. So that is the reason if the first number is x, then the next number should be taken with an addition of 2. Again the third number has to be taken with the addition of 2 on the second number and so on. So x, x plus 2, x plus 4, x plus 6 forms consecutive even numbers provided the first number x is even. Likewise, we also have consecutive odd numbers. Now consecutive odd numbers are odd numbers in a row. For example, 1, 3, 5, 7 can be treated as consecutive odd numbers. Why? Because we see they are all one after the other in succession. So these are successive odd numbers, or we can call consecutive odd numbers. Now consecutive odd numbers are also represented as x, x plus 2, x plus 4, x plus 6 and so on, where x is odd. So even consecutive odd numbers can be taken as x, x plus 2, x plus 4, x plus 6 and so on. That means the difference between two consecutive odd numbers is always 2. Plus 2 gives the next number, again plus 2 on the next number gives the third number, plus 2 on the third number gives the fourth number and so on. For example, 33, 35, 37. These are three consecutive odd numbers. So if the first number x is 33, then x plus 2, that is 33 plus 2 will give the next number, 35. And x plus 4, that means 33 plus 4, 37 gives the next odd number and so on. So the point to be observed here is consecutive even and consecutive odd numbers are always represented as x, x plus 2, x plus 4 and so on, where x is even in case of consecutive even numbers and x is odd in case of consecutive odd numbers. And always the difference between two consecutive even or consecutive odd numbers is equal to 2. Let us take the first example here based on the concept of consecutive numbers. The question is, the sum of 4 consecutive even numbers is 44. What is the sum of the original squares of these numbers? So as given here, the sum of 4 consecutive even numbers is equal to 44. And we need to find out the sum of the squares of those 4 even numbers. Now as given in the question, let us assume that the 4 consecutive even numbers are x, x plus 2, x plus 4 and x plus 6. As we have discussed earlier, consecutive even numbers can always be represented as x, x plus 2, x plus 4, x plus 6 and so on. And since there are 4 numbers, we have taken 4 terms here, where x is an even number. Now the question says sum of these 4 even numbers is equal to 44. So we can say that x plus 2 plus x plus 4 plus x plus 6 should be equal to 44. So from this we can say 4x plus 2 plus 4 is 6 plus 6 is 12 equals to 44. So very clearly the number x would be equal to 44 minus 12 is 32. 32 by 4 is 8. So x is equal to 8. Now if the first number x is equal to 8, we know that the next consecutive even number x plus 2 would be 10. Then the third consecutive number will be x plus 4, that is equal to 12. And the fourth one will be x plus 6, 14. So these are the 4 original numbers where the sum of all these 4 numbers is 44. And we are supposed to find out the sum of the squares of these numbers. So let us find out the squares of these numbers and then take the sum of those squares to get the required answer. So the sum of the first number here, that is 8 squared, will be equal to 64. 10 squared is 100. 12 squared is 144. And 14 squared will be equal to 196. So the sum of all these 4 numbers is the required answer. So we can say that the required answer as per the given question will be equal to 64 plus 100, 164, 164 plus 144 is 308, 308 and 196 will be equal to 504. So the answer for this question is 504. One important point which I would like to mention here is, instead of finding out the 4 numbers in this manner, we can directly understand that the 4 numbers are 8, 10, 12 and 14 without writing any of these steps. But for that to happen, we need to be clear with the concept of averages. So once you are done with the topic of averages, you can easily understand how to decide what are the 4 numbers when the sum is equal to 44. But since averages is not over as of now, let us go by the regular procedure. Let us now take the second example based on consecutive numbers. The question here is, the product of 2 successive numbers is 4692. What is the smaller of the 2 numbers? So as given here, the product of 2 successive numbers, that means 2 consecutive numbers, is equal to 4692. We need to find out what is the smaller of the 2 numbers. Now going by the concept, we know that the 2 successive numbers should be x and x plus 1. Remember, here it is not specified that they are consecutive even numbers or odd numbers. Simply it says successive numbers. So it should be taken as successive natural numbers. So if the first number is x, the second number would be x plus 1. And as given in the question, the product of these 2 numbers, that means x into x plus 1 is equal to 4692. Now here we have an equation with only one variable, that is x. So one equation in one variable can be solved. So if we try to expand this, we get x into x, x squared plus x minus 4692 is equal to 0. So as you can see here, this is a quadratic equation in terms of x. So by solving this quadratic equation, we will get 2 values of x, out of which one most probably would be negative and the other value has to be the answer here. But friends, solving this quadratic equation is not an easy task and that becomes a lengthy procedure. So let us understand how can we solve the question without going by solving the quadratic equation. Now to find out the correct answer for this question, that is to find out the smaller number of this question, let us eliminate the wrong options from the given options here. For example, the question here is, what is smaller of the 2 numbers? And if you look at the product here is 4692. That means the product or the multiplication of 2 numbers ends with 2. Now if we take option number 1 to be correct, that means the smaller number is 69. Very clearly, if the smaller number is 69, larger number will be 69 plus 1, 70. So if this is smaller, larger number would be 70. And 69 into 70, that means one number ends in 9, the other number ends in 0. We know that their product will end with 0. but the given product here ends with 2. So very clearly option number 1 cannot be the answer. Similarly, if you look at option number 2, it says the answer is 62. That means smaller number is 62. If smaller number is 62, larger number has to be 63. Why? Because these are consecutive numbers. So 62 into 63 will be ending in 6. Why? Because when one number ends in 2, the other number ends in 3, their product will end in 6, going by the unit space concept. So 62 into 63 should be ending in 6, but the given product here ends with 2. So very clearly even second option cannot be the answer. When we go for option number 3 here, the given number is 68. Now if this is the smaller number, the larger number has to be 69. So if one number ends in 8, the other number ends in 9, their product 8 into 9 ends with 2. But because 8 into 9 is 72, so 2 will be in the unit space and 7 gets carried forward. Now if you look at this, the product of 68 and 69 ends in 2, and even the given product here is ending with 2. So option number 3 may be the correct answer. Just because the unit space are matching, we cannot say that option 3 is the correct answer directly. We also have to verify it before we mark the answer. But let us continue and check, is it possible that fourth option is correct or not. The given answer here is 67. That means again the smaller number is 67. If smaller number is 67, larger number will be 68. And 7 into 8 ends with 6. So very clearly even option number 4 cannot be the answer. Why? Because here the product is ending in 6 and our actual product ends with 2. So as you can see here, out of the given 5 options, 3 are already eliminated. That is option number 1, option number 2 and option number 4 cannot be the answers. The correct answer has to be either option 3 or option 5, none of this. Now before we mark option 3 as the answer, what we simply need to do is find out the product of 68 and 69. If that comes out to be 4692, this should be taken as the correct answer. Otherwise, option 5 will be the correct answer. And 68 into 69 is actually 4692. So option 3 will be the correct answer. Now this product has to be actually multiplied and verified, and it will come out to be 4692. So we can say that option 3 is the correct answer. If this is not equal to 4692, then option 5 has to be the correct answer. So this is how, simply by eliminating the wrong options based on the concept of units place, you can find out what is the correct answer. In some cases, more than one option may satisfy the last digit, that is the units place. So in such cases, we need to check each of the possible options by multiplying with the next digit and find out which matches with the given product, and that has to be taken as the correct answer. Remember, there is no point in solving this quadratic equation as it is going to be a very lengthy procedure. So always it is better that we solve such questions by eliminating the wrong options. Let us now take another interesting example based on consecutive numbers. The question here is, the sum of 5 consecutive even numbers is 200. So what is the sum of the next set of consecutive even numbers? So as you can see here, for 5 consecutive even numbers, the sum is 200, and we are supposed to find out the sum of next 5 consecutive even numbers. Now as discussed earlier, the 5 consecutive even numbers can be taken as x, x plus 2, x plus 4, x plus 6 and x plus 8. And the sum of all these 5 numbers is equal to 200 as given in the question here. So if we try to simplify this equation, we get 5x plus 2 plus 4 is 6, 6 and 6 12 and 8 is 20. So 5x plus 20 is equal to 200. So from this, x will be equal to 200 minus 20, 180. 180 by 5 is 36. That means the first number is 36. Now if the first number x is 36, the remaining 4 numbers x plus 2, x plus 4, x plus 6 and x plus 8 will be equal to 38, 40, 42 and 44. So these are the 5 consecutive numbers which he is talking about. The sum of these 5 numbers is equal to 200. And we are supposed to find out the sum of next 5 consecutive even numbers. That means we need to take up the next 5 consecutive even numbers after 44 and find out the sum of those numbers. So if we try to take the next 5 consecutive even numbers, we get 46, 48, 50, 52 and 54, as 46 is the next number which comes after 44 and then followed by 48, 50, 52 and 54. So these are the 5 consecutive even numbers which comes after 44, and we need to take the sum of these 5 numbers, and the sum of these 5 numbers here will be 46 and 54 is 100, 48 and 52 is 100, plus 50 is 250. So the sum of next 5 consecutive even numbers is equal to 250. So this is how you can solve this question in the general procedure. That is by using the consecutive numbers as x plus 2, x plus 4, x plus 6 and so on. But friends, if you try to be smart, the same question can be answered without writing any of these steps. We need not even find even a single number to find out the sum of next 5 consecutive numbers. The important point to be observed here is, if we take any 5 consecutive even numbers and then try to compare with the next 5 consecutive even numbers, we find that the difference between each pair will be equal to 10. For example, let's take the first 5 consecutive numbers, consecutive even numbers, 2, 4, 6, 8 and 10. So if we try to take the next 5 even numbers, we get 12, 14, 16, 18 and 20. Now if we try to observe 2 and 12, the difference is 10, 4 and 14, the difference is 10, 6 and 16 again, the difference is 10, 8 and 18, the difference is 10, and 10 and 20, the difference is 10. That means the next 5 consecutive numbers are nothing but 10 more than each of the given consecutive numbers. So altogether we have got 5 tens extra. That will make it 50 more than the actual sum. So if this sum of these 5 numbers is equal to A, the sum of next 5 numbers has to be A plus 50. So that is the reason, if the sum of 5 consecutive even numbers is 200, it is obvious that the sum of next set of consecutive even numbers should be 200 plus 50. Why? Because each of these numbers will increase by 10 and the total increase will be 50. So directly we can say that the answer should be 200 plus 50, that is equal to 250. So without writing any of these steps and without doing any calculation, we can simply increase the total by 50 to get the required answer. And not only in case of even numbers, but also in case of odd numbers, the same rule is applicable. When we take 5 consecutive odd numbers and take the next 5 consecutive odd numbers, we find that the difference between each pair will be equal to 10. So that is how always, if you can increase the sum by 10, even in this case we observe 36 and 46, 38 and 48, 40, 50, 42, 52, 44, 54. Each number is increasing by 10. So total has to increase by 50. So friends, this is how we can answer such questions in a smart way. Before we move on to the next model, I have to mention another important point here. For 5 numbers, if the sum is increasing by 50, doesn't mean that if there are 4 consecutive numbers, the sum will increase by 40. That would be absolutely wrong. Why? Because when there are only 4 numbers, and if we take the next 4 numbers, each number will increase only by 8 but not by 10. For example, let's take 4 consecutive odd numbers, 1, 3, 5 and 7. When we take the next 4 consecutive odd numbers, that is 9, 11, 13 and 15, we find that in each of these cases, the numbers have increased by 8. 1 plus 8 is 9, 3 plus 8 is 11, 5 plus 8 is 13, 7 plus 8 is 15. That means when there are only 4 numbers, each number will increase only by 8. So altogether, the total will increase by 4 8s, that is nothing but 32. So plus 32 will give the required answer. So don't have a misconception that for 5 numbers the sum will increase by 50. So for 4 numbers it will be 40 and for 3 numbers it will be 30 and so on. You need to check what is the difference between each number. And that can be simply done by taking the first 4 consecutive odd numbers or even numbers. One simple way to understand how much each number would increase by in such cases would be to count the number of numbers. For example, when there are 4 numbers, we find that each number increases by 8. That is nothing but 4 into 2. Why? Because each consecutive even pair or odd pair will give a difference of 2. So that is the reason the total difference here is 4 into 2, 8. Similarly, when there are 5 numbers, each number gives a difference of 2. So 5 into 2, 10 will be the difference between each pair. So this is how simply understand how much is going to be the difference between each pair and then find out the total difference and add it to the given sum to find out the required answer. Let us now take the third model from this topic of number systems. In some of the questions from this topic, the divisibility test has to be conducted. That means we need to check whether the given number is divisible by a particular number or not. So in order to simplify these questions, we need to know the various rules which are to be followed to check the divisibility of the given number with various numbers. So let us first understand the divisibility rules for different numbers. Now if you look at the first one here, divisibility by 2. how to check whether a given number is divisible by 2 or not. The condition here is the number should be even. So for a number to be divisible by 2, it has to be an even number, or we can say that the last digit should be even. So it should be either 0 or 2 or 4 or 6 or 8. But because only in these cases the number becomes an even number. Now if you look at some examples here, the number 2796, this is an even number, or the last digit here is 6, which is even. So obviously the number itself is an even number. So this number is definitely divisible by 2. Why? Because all the even numbers are multiples of 2. So once it is an even number, it becomes a multiple of 2, and hence it is definitely divisible by 2. So 2796 is divisible by 2. Similarly 174, the last digit here is 4. That is again an even digit. So 174 is an even number. So even this is divisible by 2. But when we look at this number 3791, this is an odd number. And very clearly we know that for a number to be divisible by 2, it should be even. And since it is an odd number, we can say that this is not divisible by 2. So this is how we can verify the divisibility by 2 by simply checking the last digit of the given number. The next one here is divisibility by 3. So how to check whether a given number is divisible by 3 or not. The rule here is the sum of the digits of the given number should be a multiple of 3. So for a number to be divisible by 3, the sum of its digits, the sum of all its digits has to be a multiple of 3. Let us take some example and understand this. Now let's say the given number is 689154. How to check whether the given number is divisible by 3 or not? What we do here is add all the digits, and the sum, if it is a multiple of 3, this number is divisible by 3. Otherwise it is not. Let us check what is the sum of these digits. 6 plus 8 is 14, 14 plus 9 is 23, plus 1 is 24, 24 plus 5 is 29, 29 plus 4 is 33. That means the sum of all these digits here comes out to be 33. And we know that 33 is a multiple of 3. Why? Because 33 is 3 into 11. So if 33 is a multiple of 3, then this number is definitely divisible by 3. Why? Because the sum of its digits is a multiple of 3. Let us now see whether this number 32147 is divisible by 3 or not. Again, we need to find out the sum of the digits. 3 plus 2 is 5, plus 1 6, 6 plus 4 is 10, and 10 plus 7 is 17. 17 is not a multiple of 3. So this number is not divisible by 3. So this is how we can check the divisibility of a number by 3 by finding out the sum of its digits. If the sum is a multiple of 3, then the number is divisible by 3. Otherwise it is not. Let us now move to find out the divisibility rule for 4. Now for a number to be divisible by 4, the number formed by the last two digits of the given number should be a multiple of 4. So this is how we can check the divisibility by 4. Whatever number is given to us, we need to take the last two digits. That means units place and tens place. And the number formed by these two digits has to be a multiple of 4. Let us see some examples here. For example, 389416. If you look at this number, the last two digits here are 16. And because 16 is a multiple of 4, this number is divisible by 4. So simply to check the divisibility, we need to just check the last two digits. If it is a multiple of 4, then the number is divisible by 4. Otherwise, it is not. Now, if you look at the next number here, 598127, the last two digits here are 27. So the number formed by the last two digits there is 27. And 27 is not a multiple of 4. So hence, this number is not divisible by 4. So simply for a number to be divisible by 4, the last two digits have to be a multiple of 4. That means 4, 8, 12, 16, 20, 24 and so on. So this is how we can check the divisibility by 4. Now moving on to the divisibility by 5. For a number to be divisible by 5, the last digit of the number should be either 0 or 5 itself. So this is very simple. We only need to check the last digit. If it is 0 or 5, then the number is divisible by 5. Otherwise it is not. So some simple examples here are 18975. Here the last digit is 5. So this is divisible by 5. In second example 32690, the last digit is 0. So hence this number also is divisible by 5. But in the last case here, that is 1,87,173, the last digit is 3. And hence we can say that this number is not divisible by 5. Why? Because it should either be 5 or 0 for it to be divisible by 5. So this is how we can verify the divisibility of 2, 3, 4 and 5. The next one here is divisibility by 6. Now a number is divisible by 6 if it is divisible by 2 and 3. So for a number to be divisible by 6, it should be divisible by 2 as well as 3. And we have already learned the divisibility rule for 2 and 3. That means for a number to be divisible by 2, it has to be an even number, because that's the divisibility rule for 2, and at the same time the sum of its digits should be a multiple of 3, but because that is a divisibility rule for 3. So when both the divisibility rules of 3 and 2 are satisfied, then the number is divisible by 6 as well. For example, if you look at the first one here, 918654, this number is divisible by 2 because the last digit here is even, or the number here is an even number. So it is divisible by 2. Let us now check the divisibility of this number by 3. Now we know that divisibility for 3 is sum of the digits has to be a multiple of 3. So sum of the digits here, 9 plus 1, 10, 10 and 8, 18, plus 6, 24, plus 5, 29, plus 4, 33. So this number 33 is a multiple of 3. Hence the given number here is divisible by 3 also. So as it is divisible by both 2 and 3, we can say that this number is divisible by 6. Moving on to the next example, 43172, that is 43,172. Now as the given number is even, it is divisible by 2. Let us now see the divisibility by 3. 4 plus 3 is 7, plus 1 8, plus 7 15, plus 2 17. 17 is not a multiple of 3. Hence this number is not divisible by 3. So we can see that the number given here is divisible by 2 but not by 3. Hence it is not divisible by 6. Why? Because for it to be divisible by 6, it should be divisible by both 2 as well as 3. Now in the third example here, 69321, the number is odd, and hence we can say that it is not divisible by 2. And once a number is not divisible by 2, it will not be divisible by 6 also. So even this number is not divisible by 6. Let us now see what is the divisibility rule for 8. Now for a number to be divisible by 8, the number formed by last 3 digits of the given number should be a multiple of 8. So that's like 4. In case of 4, we see that the last 2 digits have to be a multiple of 4. But in case of 8, the last 3 digits have to be a multiple of 8. Only then the given number is divisible by 8. Let us take some examples and understand this. The number here is 13840. So the last 3 digits here are 840. So the number formed by last 3 digits is 840. And 840 is a multiple of 8. So we can say that the given number 13840 is divisible by 8. Now if you look at the next example here, it is 643151. The number formed by the last 3 digits 151 is not a multiple of 8. Hence this number is not divisible by 8. So simply to check whether the given number is divisible by 8 or not, we need to just verify the last 3 digits. If the last 3 digits form a multiple of 8, or if they are divisible by 8, then the complete number is divisible by 8. Otherwise it is not. Moving on to the divisibility rule for 9. Now for a number to be divisible by 9, the sum of the digits of the number should be a multiple of 9. So that's exactly like 3. In case of 3 as well, we see that if the sum of the digits is a multiple of 3, then the number is divisible by 3. Let's take some examples to understand this. The number here is 9516348. So that's like 95,16,348. Now that's a huge number. And to check whether this is divisible by 9 or not, in the general procedure would take a lot of time. So instead of that, simply check the sum of the digits. So 9 plus 5 is 14, 14 plus 1 is 15, plus 6 is 21, plus 3 is 24, plus 4 is 28, and plus 8 is 36. That means sum of the digits here is 36. And 36 is a multiple of 9. 9 into 4 is 36. So as the sum of the digits here is a multiple of 9, we can say that the given number is divisible by 9. The other example here is 172356. Let us see if this number is divisible by 9 or not. The sum of the digits here, 1 plus 7 8, plus 2 10, plus 3 13, plus 5 18, plus 6 24. 24 is the sum of the digits, and we very well understand that 24 is not a multiple of 9. So we can say that the given number here is not divisible by 9. So that's how we check the divisibility for 9. The sum of the digits have to be a multiple of 9. Moving on to the divisibility rule for 10. For a number to be divisible by 10, the last digit of the number should be 0. So like in case of 5, the last digit has to be 0 or 5. But in case of 10, the last digit should be only 0. Only then the number is divisible by 10. If we take some examples here, this number 4953270, we find that the last digit is 0. Hence, directly we can say this number is divisible by 10. But if you look at the number 137736, the last digit is 6. And hence, this number is not divisible by 10. So that's how we check the divisibility for 10. Let us now learn how to check the divisibility by 11 and 12. A number is divisible by 11 if the difference between the sum of the digits in alternate positions should be a 0 or a multiple of 11. So for a number to be divisible by 11, the difference of the sums of the digits in alternate positions has to be 0 or a multiple of 11. Let us understand this with the help of some examples. Now, as you can see here, the number is 275. What we need to do here is find out the difference between the sums of alternate positions. For example, we have to first of all find out the sums of alternate positions. So 2 and the alternate position is 5. So 2 plus 5 is 7. So sum of these alternate positions here is 2 plus 5, which is equal to 7. And the other left out position is only 1, that is 7. So the sum itself can be taken as 7. Now we see that one of the sums is 7, the other sum is also 7. And the difference between these two sums, 7 minus 7, is 0. So as given here, if the difference is 0 or a multiple of 11, the number is divisible by 11. So we can say that 275 here is divisible by 11. Let us take one more example to understand this. As given here, we first need to find out the sum of alternate positions. So let us find out the sum of alternate positions here. 6 plus 7 plus 8 plus 2. So as you can see, we are taking all the alternate positions. 6 plus 7 is 13. 13 plus 8 is 21. 21 plus 2 is 23. So one of the sums is 23. Let us now take the sum of the other alternate positions. 4, 3, 2 and 3. 4 plus 3 is 7. 7 plus 2 is 9. 9 plus 3 is 12. So the other sum here is 12. And the difference between these two sums, 23 difference 12, is equal to 11. Now since the difference is 11, we know that the difference should be either 0 or multiple of 11 for the number to be divisible by 11. So since the difference here is 11, it is nothing but a multiple of 11. So we can say that even the second number here is divisible by 11. So that's how we only need to find out the sums of the alternate positions and then take the difference between these two sums. If it is 0 or a multiple of 11, then the number is divisible by 11. Let us take one more example. Here the sum of alternate positions, 8 plus 9 plus 0. 8 plus 9 is 17 plus 0 is 17. And the other sum, that is 1 plus 2 is 3. 17 difference 3 will be equal to 14. And since 14 is not a multiple of 11, we can say that this number is not divisible by 11. So that's how we check the divisibility for the number 11. Let us now see the divisibility rule for 12. For a number to be divisible by 12, it has to be divisible by both 3 and 4. So the simple point here is, if a number is divisible by 3 as well as 4, then it is divisible by 12. Let us check this with some examples. We already know the divisibility rules for 3 and 4. A number is divisible by 3 if the sum of the digits is a multiple of 3. And it is divisible by 4 if the last two digits make a number which is multiple of 4. So let us check which of these numbers satisfy both the conditions. Now since it is easy to check the divisibility for 4 when compared to 3, let us first check the divisibility for 4. Now if you look at the number here 13764, the last two digits are 6 and 4. That means the number formed by the last two digits is 64. And 64 is a multiple of 4. 64 is nothing but 4 into 16. So this number is divisible by 4. And if 64 is divisible by 4, then the complete number is divisible by 4. Let us now see, is it divisible by 3 or not. Now for 3, we need to check the sum of the digits. 1 plus 3, 4. 4 plus 7 is 11. 11 plus 6 is 17. Plus 4 is 21. That means the sum of the digits here is 21. And 21 is a multiple of 3. So this number is definitely divisible by 3. So as we have seen here, it is divisible by 4 as well as 3. So we can say that this number is divisible by 12. Let us now take one more example. 415276. Here the last two digits are 7 and 6. So the number formed by the last two digits is 76. And 76 is a multiple of 4. So this number is divisible by 4. Let us see, is it divisible by 3 or not. 4 plus 1, 5 plus 5, 10 plus 2, 12 plus 7, 19 plus 6 is 25. So sum of the digits here is 25, and 25 is not a multiple of 3. Hence, this number is not divisible by 3. And if it is not divisible by 3, even though it is divisible by 4, then it cannot be divisible by 12. Why? Because for a number to be divisible by 12, it should satisfy the conditions for 3 as well as 4. So the condition for 4 is satisfied, but not for 3. So we can say that this number cannot be divided by 12. Let us now check the divisibility for some special cases, that is divisibility by 7 and 19. Now these are two peculiar numbers where we have a step-by-step procedure to find out whether the given number is divisible by 7 and 19 or not. Let us first take the divisibility for 7. What we do here is the given number is split into two parts. That means from the given number, the units place is separated and the remaining part of the number is taken. Now the units place is multiplied with 2 and subtracted from the remaining part of the answer. And this procedure is continued till we get a 2-digit or a 3-digit number where we can easily observe whether the given number is divisible by 7 or not. Now if the number obtained is divisible by 7, then the whole number is divisible by 7. Otherwise it is not. Let us understand this with some examples. For example, here the given number is 224. Now how to check whether the number 224 is divisible by 7 or not? See, as such we know that 224 is 7 into 32. That's an easy example, but to understand the procedure, let us start with a simple one. So as I have mentioned, what we need to do here is break the number into two parts. That means units place should be separated from the remaining part of the number. So if we separate the units place from 224, we get 22 and 4. Now this number 4 should be multiplied with 2 and subtracted from the remaining part of the answer. So units place multiplied with 2 and subtracted from the remaining part. 22 minus 8. 22 minus 8 is equal to 14. And since 14 is divisible by 7, we can say that 224 is also divisible by 7. So that's how we check the divisibility for 7. What we need to do is separate the units place from the remaining part of the answer, multiply the units place with 2 and subtract from the remaining part. And this procedure has to be continued till we get a 2-digit or a 3-digit number where it is easy to observe the divisibility by 7. So if the answer obtained is divisible by 7, then the whole number is divisible by 7. Otherwise it is not. Let us now take another example, that is 16751, 16,751. So as discussed, units place has to be separated from the remaining part. So 1675, units place should be multiplied with 2, 1 into 2 and subtracted from the remaining part. So what do we get? 1675 minus 2 is 1673. Again 3 has to be separated, multiplied with 2 and subtracted from the remaining part. So we get 167 minus 3 into 2 is 6. 167 minus 6 is 161. After getting 161, if you are able to say that is it divisible by 7 or not, then you can directly understand the divisibility. Otherwise, continue the procedure for one more step. So again, by separating the units place, we get 16 minus, this units place should be multiplied with 2. 1 into 2 is 2. 16 minus 2 is 14. Now we know that 14 is divisible by 7. So we can say that 16751 is also divisible by 7. So that's how it is. Always in each step, separate the units place, multiply with 2 and subtract from the remaining part of the answer. This has to be continued till we get a 2-digit number. Let us now check this for 38274. So here we get 3827 minus 4 multiplied with 2. That will give us 38. 27 minus 8 is 19. So we get 3819. Again 381 minus this units place multiplied with 2, that is 18. So 381 minus 18 will be equal to 363. Again from 363 we can separate the units place. So 36 minus 3 into 2, 6 will be equal to 30. We know that 30 is not divisible by 7. So we can say that this number cannot be divided by 7. So that's how we check the divisibility for 7. Now coming to the divisibility by 19, the procedure here is similar to what we have done in case of 7. But the only difference is instead of subtracting the units place multiplied with 2, we need to add the units place multiplied with 2. Let's take some examples and understand this. For example, here we have 399. Now 39 and 9 are to be separated. That means units place is separated from the remaining part. And 9 should be multiplied with 2. And this is added to the remaining part of the answer. So 39 plus 9 into 2 is 18, and this is equal to 57. We know that 57 is divisible by 19. 57 divided by 19 is equal to 3. So if 57 is divisible by 19, we can say that 399 as well is divisible by 19. Let us take one more example, that is 11096. Here we get 1109, 6 is separated, multiplied with 2. 6 into 2 is 12, and it is added to the remaining part of the answer. So 1109 plus 12 will be equal to 1121. Again, in 1121 we can take 112 separate, and this should be added to units place multiplied with 2. 1 into 2 is 2. So 112 plus 2 is 114. Again, moving on, 11 plus, that means the remaining part of the answer, units place multiplied with 2. 4 into 2 is 8. 11 plus 8 is 19. Now 19 is divisible by 19. So very clearly even this number is divisible by 19. So that's how we can check the divisibility for 19. So 7 and 19 are similar to each other. The only point here is, in case of 7, we separate the two numbers. That means units place is separated from the remaining part of the number. Units place multiplied with 2, and it is subtracted from the remaining part. But in case of divisibility by 19, the units place is separated, multiplied with 2, and added to the remaining part of the number. And this procedure here is continued till we get a 2-digit number, where we can easily check whether the number is divisible by 7 or 19 or not. Now, after learning about the divisibility rules for the first 10 numbers and some special cases, let us now see how to in general decide that whether a given number is divisible by a particular number or not. So let's see the divisibility for other numbers. Other numbers like 14, 15, 18, etc. Now, as we have seen, in case of 6, the divisibility rule for 6 is that the given number has to be divisible by 3 as well as 2. It should be divisible by 3 and 2. Similarly, in case of 12, the divisibility rule was the number has to be divisible by 3 and it should be divisible by 4. So let us understand how to decide which two numbers have to be satisfied for a particular number to have its divisibility. So let us now try to understand why do we take 3 and 2 for 6 and why do we take 3 and 4 for 12. Once we understand this, you will get to know how to check the divisibility for various other cases. Now, to understand this, first of all, we need to know what are coprimes. Coprimes. Coprimes or relative primes is a set of numbers where the highest common factor is equal to 1. For example, 5 and 3 or 3 and 5 can be taken as coprimes. Why? Because factors of 3 are 1 and 3. Factors of 5 are 1 and 5. Now here the highest common factor or the only common factor is 1. So 3 and 5 are coprimes. So numbers where the highest common factor is equal to 1 are considered to be coprimes or relative primes. Let us take one more example. For example, 8 and 9. Even 8 and 9 are coprimes. Why? Because the factors of 8 are 1, 2, 4 and 8 and the factors of 9 are 1, 3 and 9. Now, as you can see here, the highest common factor is 1 for 8 and 9. So even 8 and 9 are considered to be coprimes. Likewise, 15 and 16 are also considered as coprimes. Why? Because factors of 15 are 1, 3, 5 and 15 and factors of 16 are 1, 2, 4, 8 and 16. So as you can see here, the only common factor which they have is 1 and 1 itself becomes the highest common factor. So 15 and 16 are also considered as coprimes or relative primes. The other important point that you have to observe here is coprimes or relative primes doesn't mean that both the numbers or all the numbers have to be prime. For example, in the first case, 3 and 5 both are prime in nature, but 8 and 9 if we take, both are composite. And similarly, 15 and 16 are also composite. So the point to be understood here is coprimes doesn't mean that both the numbers have to be necessarily prime. They can be prime or composite. The only condition which has to be satisfied is their highest common factor has to be 1. Such numbers are considered as coprimes. After learning about coprimes, it will now be easy for us to understand why do we take 3 and 4 as the divisibility rule for 12 and why do we take 3 and 2 for 6. For example, let us consider 12 here. Now, to check the divisibility for 12, first of all, we need to factorize the number 12 as a product of two numbers. That means we should be able to write 12 as a product of two of its factors. For example, 12 can be taken as 1 into 12 or it can be taken as 2 into 6 or 3 into 4. So these are the different ways in which 12 can be taken as product of two numbers. So out of these three cases, we need to take up that particular case in which both the factors are co-primes. And always factorization with 1 has to be neglected. So leaving out 1 into 12, the two possible cases are 2 into 6 and 3 into 4. Now out of these two cases, when we take 2 and 6, the factors of 2 are 1 and 2 and factors of 6 are 1, 2, 3 and 6. And the highest common factor here is 2. And since the highest common factor is 2, 2 and 6 cannot be co-primes. Why? Because for two numbers to be co-primed, their highest common factor has to be 1. So even 2 and 6 is ruled out. Now the only possible case is 3 and 4, and 3 and 4 both are co-primes. Why? Because factors of 3 are 1 and 3 and that for 4 are 1, 2 and 4. So since only 1 is the common factor, that itself becomes the highest common factor. So 3 and 4 has to be taken as the correct way of taking 12 as product of two numbers. Now that is the reason we take the divisibility for 12 as divisible by 3 and divisibility by 4. Likewise, we can understand it for 6 as well. Let us now take one of these numbers and understand what would be the divisibility rule for them. For example, let us consider 18 here. So as we have discussed, first of all we need to write 18 as product of two different factors. So 18 can be taken as 1 into 18, or it can be taken as 2 into 9, or it can be taken as 3 into 6. So these are the various ways in which 18 can be taken as product of two numbers. Apart from this, we have 6 into 3, which is same as 3 into 6, 9 into 2, which is same as 2 into 9, or 18 into 1. Now as discussed earlier, 1 into 18 has to be ruled out. Why? Because here if we take 1 and 18, the divisibility for 18 would be that the number has to be divisible by 1 and divisible by 18. That doesn't make any sense. Now out of the remaining two cases, we need to take up that particular one where the given factors are co-primes. 2 and 9 will be co-primes. Why? Because factors of 2 are 1 and 2 and factors of 9 are 1, 3 and 9. 1 is the highest common factor. So the divisibility for 18 would be that the number is divisible by 2 as well as it is divisible by 9. And when we take 3 and 6, we know that highest common factor of 3 and 6 will be equal to 3. Since the highest common factor is 3 and not 1, 3 and 6 are not co-primes. So the divisibility for 18 will be that the number has to be divisible by 2 and it should be divisible by 9. Likewise, we can check for the remaining numbers as well. For example, if you go for 15, we find that for 15 the rule should be that the number is divisible by 3 as well as 5. And similarly for 14, it should be that the number should be divisible by 2 and by 7. So this way, always try to factorize the given number into product of two numbers and then check which of these pairs is a co-prime. That particular pair can be taken as a divisibility rule for the given number. Let us now take the first example from model 3, which is based on the divisibility rules. The question here is, what is the smallest number that should be added to 89357 to make it divisible by 9? So we need to find out what number has to be added, what smallest number has to be added to this number 89357 such that it becomes divisible by 9. That means as of now, the given number 89357 is not divisible by 9. If we add something, only then it becomes divisible. So we need to find out what smallest number can be added so that it becomes divisible by 9. One way of solving the question here is to divide the number 89357 by 9 and find out the remainder. And depending on remainder, we can decide what has to be added so that the number becomes divisible by 9. But that becomes a lengthy procedure. Why? Because dividing 89357 by 9 itself may take about 10-15 seconds. So let us understand what is the smart way of solving the question here. We know that a number is divisible by 9 only when the sum of its digits is a multiple of 9. So let us first check what is the sum of the digits in case of 89357. So 8 plus 9 plus 3 plus 5 plus 7. 8 plus 9 is 17 plus 3 is 20 plus 5 is 25 and plus 7 is 32. That means the sum of the digits is 32. Now since 32 is not a multiple of 9, we can understand that the given number is not divisible by 9. Now the question here is what should be added so that it becomes divisible by 9. So let us first of all understand what should be added to 32 so that it becomes divisible by 9. We know that the very next number after 32, which is a multiple of 9, is 36. And 36 can be obtained by adding 4 to this number. So once we add 4 to 32, it becomes 36 and 36 is a multiple of 9. Hence, this number is divisible by 9. So very clearly, by adding 4, we get a sum which is divisible by 9, or which is a multiple of 9. So if we add 4 to this number, the sum will increase by 4. The sum of the digits will also increase by 4, and hence we can say that the given number is divisible by 9. So the correct answer for this question should be 4. That means we need to add 4 so that the number becomes divisible by 9. So very simple point here is find out the sum of the digits and just check what should be added to this sum so that it becomes divisible by 9. The same number when added to the given number makes it divisible by 9. Similarly, let's see what should be subtracted from this number so that it becomes divisible by 9. Now as we know that the sum of the digits is 32, and if we subtract 5 from 32, this becomes divisible by 9. Why? Because 32 minus 5 is equal to 27, and 27 is a multiple of 9. So we can say that this number becomes divisible by 9 when we subtract 5 from it. So this is how we can solve questions related to addition or subtraction of a smallest number to the given number so that it becomes divisible by 9. Let us now take one more example which is based on the rules of divisibility that we have learned. The question here is, what is the smallest digit which should replace the star in the number 296 star 12 to make it divisible by 12? So that's an interesting question. We need to find out what should come in place of star in the given number such that this number becomes divisible by 12. And the options are 1, 2, 3, 4, and the fifth option is none of this. Now the given number here is 296 star 12, and this number has to be divisible by 12. We very well know that a number is divisible by 12 only when it is divisible by 3 and by 4. So let us go by the divisibility for 3 and 4 to check what comes in place of star. Let us first of all find out the divisibility by 4. We know that a number is divisible by 4 only when the last 2 digits is a multiple of 4. Now here the last 2 digits 12 is a multiple of 4. So definitely this number is divisible by 4. Let us now go for the divisibility for 3. So as the number is divisible by 4, let us now check for 3. We know that a number to be divisible by 3, the sum of its digits has to be a multiple of 3. So let us find out the sum of the digits in this case. As you can see here, the sum of the digits is 2 plus 9 plus 6 plus star plus 1 plus 2. So let us add all the digits here. 2 plus 9 is 11, plus 6 17, plus 1 is 18, and plus 2 is 20. And the left out value here is star. So the sum of the digits is 20 plus star. Now since we are checking the divisibility for 3, we know that this sum has to be a multiple of 3, or it should be divisible by 3. So we should find out that value in place of star so that 20 plus the value becomes a multiple of 3. And since he is asking for the smallest digit, we need to find out the smallest such value which can make it divisible by 3. Now if we go by the options, that is option number 1, we find that 20 plus 1, that means if star is equal to 1, the number becomes 20 plus 1, 21. 21 is a multiple of 3. So definitely if star is replaced by the number 1, this number becomes divisible by 3. Since 21 is divisible by 3, the whole number will also become divisible by 3. So that is how we can say that the answer for this question has to be option number 1, that is equal to 1. Let us now take the fourth model from this topic of number systems, which is based on the various fundamental formulae from algebra. When it comes to bank exams, we don't have algebra as a separate topic, but then the basic formulae will be required in solving some questions from number systems. So first of all, let us understand the basic fundamental formulae from algebra. The first one here is a plus b whole squared. A plus b whole squared is equal to a squared plus 2ab plus b squared. Next is a minus b whole squared. That should be taken as a squared minus 2ab plus b squared. That means when a plus b whole square or a minus b whole square is expanded, we get the forms as shown on the right hand side. That means when a plus b whole square or a minus b whole square is expanded, the product obtained will be as shown on the right hand side. Next comes a plus b whole cube. A plus b whole cube is equal to a cube plus 3a squared b plus 3ab squared plus b cube. Or this can be taken as a cube plus b cube plus 3ab into a plus b. Likewise, a minus b whole cube is a cube minus 3a squared b plus 3ab squared minus b cube. And again, it can also be taken as a cube minus b cube minus 3ab into a minus b. The fifth one here is one very important concept, that is a plus b into a minus b should always be taken as a squared minus b squared. Why? Because when we multiply these two, what we get is a squared minus b squared. The next one here is a cube plus b cube. A cube plus b cube can be taken in the form of a plus b into a squared minus ab plus b squared. And a cube minus b cube can be taken as a minus b into a squared plus ab plus b squared. And the last one here is a plus b plus c whole square, which is equal to a squared plus b squared plus c squared plus 2ab plus 2bc plus 2ca. Generally, these formulae can be applied while solving questions from simplifications, and they can also be used in certain questions from the topic of number systems. Let us now take an example from Model 4 where we are going to solve a question based on the various formulae that we have just discussed. The question here is, the difference between two numbers is 4 and the difference between their squares is 128. What is the larger number? So as given here, there are two numbers. The difference between the two numbers is 4 and the difference between their squares is 128. We are supposed to find out the larger number. Let us assume that the two numbers are L and S. L means the larger number and S means the smaller number. So as given in the question, the difference between the two numbers is 4. So we can say that L minus S is equal to 4. But because larger minus smaller will be equal to 4. Otherwise, if we take S minus L, it becomes minus 4. So that is why we should take it as L minus S. The second point here is the difference between their squares is 128. That means L squared minus S squared should be equal to 128. That is the difference between their squares. Now from the discussion of the various formulae, we know that this is in the form of a squared minus b squared, and a squared minus b squared is nothing but a plus b into a minus b. So this can be expanded as L plus S into L minus S equals to 128. And from the first point here, we know that L minus S is equal to 4. So by substituting that in this second equation, we get L plus S into 4 equals to 128. And if we try to simplify this, 4 gets cancelled here 32 times. So we can understand that L plus S is equal to 32. And from the first statement, we know that L minus S is equal to 4. So by solving these two equations, we can find out the larger number. Let us add both the equations. L plus L is 2L, plus S and minus S gets cancelled, and 4 plus 32 is 36. So 2L is 36. That means L is equal to 18. So very clearly the larger number here is 18, which is given in option number 4. So this is how you can use the formulae that we have discussed in solving certain questions from number systems. But friends, to solve this question, we can even go by options instead of writing all these steps. What we need to do here is just check from the options whether the two conditions are satisfied or not. Whichever option satisfies both the conditions, that can be taken as the correct answer. So let us understand how can we solve this question by eliminating the wrong options. Now, as you can see here, the question says what is the larger number. If we take option number 1 to be correct, that means larger number is 14. If larger number is 14, it is very clear that smaller number has to be 10. Why? Because the difference between these two is 4. So if larger is 14, smaller will be 10. We know that 14 squared is 196 and 10 squared is 100. 196 minus 100 is 96. But the question says difference between their squares is 128. That means this option does not satisfy the given condition. So it can be ruled out. Option number 1 cannot be the answer. Similarly, if you look at option number 2, 16, it means the larger number is 16. If larger is 16, smaller has to be 12. Why? Because difference between the two numbers is 4. Now, let us find out the difference between their squares. 16 squared is 256 and 12 squared is 144. The difference between these two numbers here is 112. But we are looking for a difference of 128. So very clearly, even second option gets cancelled. Moving on to third option, if the larger is 12, smaller has to be 8. 12 squared is 144 and 8 squared is 64. 144 minus 64 will be equal to 80. But the question says the difference should be 128. So even the third option gets cancelled. Now the left out option here is option 4, 18. If 18 is a larger number, smaller number has to be 14. 18 square we know is equal to 324 and 14 square is 196. And 324 minus 196 is equal to 128. 324 minus 196 is 128. That means very clearly the difference of their squares is equal to 128, which is as given in the question here. So since this option satisfies the given condition, we can take it to be the correct answer. So either you can go by this step-by-step procedure or simply check which of the given options are correct by following the given conditions. Let us now take the second example based on the various formulae from algebra that we have learned. Now this is like a simplification question which is 0.8 into 0.8 into 0.8 plus 1.2 into 1.2 into 1.2 divided by 0.8 into 0.8 minus 0.8 into 1.2 plus 1.2 into 1.2. So we need to simplify this and find out what is the answer. Now friends, if you look at this question, it really appears to be a complicated one. But then if you understand the formula which is to be applied here, the answer can be obtained in a few seconds. Now let us first of all simplify this in a proper form. For example, 0.8 into 0.8 into 0.8 can be taken as 0.8 whole cube plus 1.2 into 1.2 into 1.2 is 1.2 cube divided by 0.8 into 0.8 is 0.8 squared minus this is 0.8 into 1.2 as it is plus 1.2 into 1.2 is 1.2 squared. So this is equal to what is the question? We know that a cube plus b cube is equal to a plus b into a squared minus ab plus b squared. And this can be taken as a cube plus b cube divided by a squared minus ab plus b squared should be equal to a plus b. That means simply the second part here is taken in the denominator on the left hand side. Now if you try to compare the given question with this equation, we find that it is exactly in the form of a cube plus b cube divided by a squared minus ab plus b squared, and the answer has to be a plus b. So in the given question, a is equal to 0.8 and b is equal to 1.2. So 0.8 plus 1.2 is equal to 2.0. So the answer for this question is 2. So this is how you can solve such questions by applying the proper formula among the various formulae that we have discussed. Remember friends, if you don't get this idea of solving the question, then it is better that you leave this question and go to the next one. Why? Because if you go for the regular solution of this problem, it is going to take a really very long time. And in that time, you can solve 3 or 4 other simple questions. So better you leave this if you don't get this idea. And if you are smart enough, you can understand which formula is to be applied and get the required answer in just 4 to 5 seconds. Let us now take the next model from the topic of number systems, where we are going to solve questions related to exponents or indices. Now to solve questions related to exponents, we should first of all learn the various rules or laws of exponents. So let us understand the different laws of exponents and then we shall proceed to take some examples. The first one here is a power m into a power n is equal to a power m plus n. That means whenever the bases are equal, here as you can see a and a, whenever the bases are equal and in multiplication form, the powers can be added. For example, 3 power 2 into 3 power 7 can be taken as 3 power 2 plus 7, which is equal to 3 power 9. Why? Because the bases are equal and they are in multiplication form. So the powers can be directly added. The next one here is a power m divided by a power n equals to a power m minus n. So whenever the bases are equal and in division form, the powers can be subtracted. For example, 8 power 7 divided by 8 power 3 can be taken as 8 power 7 minus 3, which is equal to 8 power 4. So since the bases are equal and in division form, their powers can be subtracted. So we get 8 power 4. The third rule here is a power m whole to the power of n will be equal to a power m into n. For example, 2 power 4 whole squared will be equal to 2 power 4 into 2, which is equal to 2 to the power of 8. So the powers here can be multiplied. 4 into 2 is equal to 8. The fourth rule here is a power m into b power m will be equal to a into b whole power m. So whenever the powers are equal, the bases can be multiplied if they are in multiplication form. For example, 2 power 8 into 3 power 8 can be taken as 2 into 3, that is 6 power 8 as per the given rule. The next point is a power m divided by b power m will be equal to a divided by b whole to the power of m. So like rule number 4, whenever the powers are equal and the bases are in division form, they can be divided and taken whole to the power of the given value. For example, 3 power 7 divided by 4 power 7 can be taken as 3 by 4 whole to the power of 7. Why? Because here the powers are equal and the bases are in division form. So we can take it as 3 by 4 whole to the power of 7. Moving on to the next one, it says a power minus m is equal to 1 by a power m. So whenever we have a negative power or negative exponent, it can be taken in the denominator with a positive value. For example, if it is 3 power minus 5, it can be equated as 1 by 3 power 5. So once you take the base in the denominator, the sign of the power changes. The next one is mth root of a can be taken as a power 1 by m. For example, square root of 4 is nothing but 4 power 1 by 2. Why? Because this is second root of 4, so it can be taken as 4 power 1 by 2. Similarly, cube root of 27 can be taken as 27 power 1 by 3. So that is what is given in rule number 7. Mth root of a is equal to a power 1 by m. Moving on to the next one, a power p by q will be equal to qth root of a power p. For example, let's say we have 2 to the power of 3 by 2. So this can be taken as second root of 2 cube. That is nothing but qth root of a to the power of p. Now this is equal to second root of 8 or nothing but square root of 8. Why? Because 2 cube is equal to 8. So this can be further simplified as per the requirement. And the last one here is a power 0 is equal to 1. So any base raised to the power of 0 will always be equal to 1. For example, 12 to the power of 0 is equal to 1 or 3 to the power of 0 is equal to 1. So whatever be the base, when the power is 0, the answer will be equal to 1. So these are the various laws of exponents or indices which are required in solving questions from this area. Let us now take an example from model 5 of number systems where we are going to solve a question related to exponents. And to solve this question, we need to use the various laws or rules that we have learned just now. The question here is 2 power 0.2 into 64 into 8 power 1.3 into 4 power 0.2 is equal to 8 power question mark. And we are supposed to find out what comes in place of the question mark here. To solve this question, as we can see that the base on the right hand side is equal to 8. So all the bases on the left hand side should be made equal to 8 with the help of different rules that we have learned. So let us see how can we convert everything in terms of the base 8 on the left hand side. If you observe, this is 2 power 0.2 and the other term here is 4 power 0.2. We know that a power m into b power m is equal to a into b whole power m. Now here, since the powers are equal, 0.2 and 0.2, the bases can be multiplied. So this can be taken as 2 into 4 whole to the power of 0.2. And the remaining part of the question is 64 into 8 power 1.3. So that can be simplified as 2 into 4 is 8 power 0.2 into 64 into 8 power 1.3. The next step here is 64 is nothing but 8 squared. 64 is equal to 8 squared. So this can be replaced with 8 squared. So this becomes 8 power 0.2 into 8 squared into 8 power 1.3. Now we see that all the bases here are equal to 8. Now we know that a power m into a power m will be equal to a power m plus n. That is, whenever the bases are equal and in multiplication form, the powers can be added. So here we find that all the bases are equal and they are in multiplication form. So the powers here can be added. So the answer will be 8 power 0.2 plus 2 plus 1.3, which is equal to 8 power 0.2 plus 2 is 2.2 plus 1.3 is 3.5. So we can say that the value that comes in place of question mark will be equal to 3.5. So this is how, with the help of various rules, that is a power m into b power m equals to a into b whole power m and a power m into a power n equals to a power m plus n, we can solve this question. Similarly, the other rules can be required depending on the question given to us. So we should be properly able to use the various rules or laws of indices to solve such questions. Let us now take model 6, which is based on arrangement of the given fractions in either ascending order or descending order. Here a number of fractions are given to us and we are supposed to arrange them in the proper order, and sometimes we are asked to find out the highest fraction or the smallest fraction. Let us look at the example here. The question says arrange the given fractions in ascending order, and the fractions given are 9 by 17, 7 by 23, 11 by 21 and 13 by 19. So we need to arrange all these fractions in ascending order. We know that ascending order is nothing but an increasing order. That means the smallest fraction should come first and the largest fraction should come last. So we need to arrange them in such a way that the smallest of these fractions is first and the largest of these fractions is last, and the remaining two fractions are in the proper order. Friends, arrangement of fraction can be done in a number of ways. One method to arrange the fractions would be to directly divide each one of them and find out the answers in terms of decimals, and then simply arrange them as per the order. The other way of arranging them would be cross multiplication of fractions. Let us understand what is meant by cross multiplication. For example, let's say we have to compare the two fractions 9 by 17 and 7 by 23. So what we do here is take the fractions 9 by 17 and 7 by 23 and do the cross multiplication. That means numerator of one fraction is multiplied with the denominator of other, and denominator of one fraction is multiplied with the numerator of other. So what we get, 9 into 23 on one side and 17 into 7 on the other side. 9 into 23 is 180 plus 27, 207, and 17 into 7 is 70 plus 49, that is 119. We know that 207 is greater than 119. That means the left hand side here is greater than right hand side. So if left hand side is greater than right hand side, we can say that the left fraction is greater than the right fraction. So definitely 9 by 17 is greater than 7 by 23. This is how we can compare two fractions with the help of cross multiplication. But friends, going by cross multiplication to arrange four fractions in ascending or descending order will become a very lengthy procedure. Why? Because here we need to do multiple comparisons. For example, once the first two fractions have been compared, we can say that the correct order should be 7 by 23 and then followed by 9 by 17. Why? Because we are arranging them in increasing order. So smaller fraction should come first. So 7 by 23 is first, followed by 9 by 17. Again, this 9 by 17 should be compared with the third fraction. That is, 9 by 17 should be cross multiplied with 11 by 21. Now by cross multiplication we get that 9 into 21 is 189 and 17 into 11 is 187. Again we find that the left hand side is greater than the right hand side. That means the left fraction is greater than the right fraction. So again 9 by 17 comes on this side and 11 by 21 should go there. Why? Because we are trying to form the ascending order or the increasing order. So this will say that the order should be 7 by 23 followed by 11 by 21 and then 9 by 17. But the problem now is, again these two fractions have to be compared. Why? Because we have not compared these two fractions. What we know so far is that both the fractions here are lesser than 9 by 17. Or 9 by 17 is greater than both the first and second fractions. But among first and second fraction, which is greater or smaller is not known. So again we have to cross multiply them and find out the correct order. So this way multiple comparisons have to be done, and finally we get the answer after 5 or 6 comparisons. So that is why going by cross multiplication becomes a lengthy procedure. The other way of comparing these fractions and arranging them in the proper order would be to take the LCM of the denominators. For example, let's say we have two fractions 3 by 4 and 5 by 8. Now whenever we have to compare these two fractions 3 by 4 and 5 by 8, what we can do is take the LCM of the denominators, or that is nothing but make the denominators equal. So that can be done by taking the LCM. That means 8 and 4, the LCM is 8. So both the denominators can be taken as 8. Now 4 is taken as 8 by multiplication with 2. If the denominator is multiplied with 2, even numerator gets multiplied with 2. So 3 by 4 becomes 6 by 8, and this is 5 by 8. So as you can see here, 6 by 8 has to be greater than 5 by 8. Why? Because the denominators are equal. So whenever the numerator is more, fraction will be more if the denominators are equal. So the same process can be applied here as well. And to do that, we have to find out the LCM of all the denominators and accordingly find out the numerators. And once we get the new numerators, the fractions can be arranged as per the numerators obtained. Why? Because the denominators are all equal. So whichever numerator is more, that fraction would be more. But even that process here seems to be complicated because the denominators here are typical. Most of them are prime numbers. So LCM would be the product of all these numbers. And again, finding out the new numerators will become a tedious task. So going by LCM here is not so useful. The third way of comparing fractions would be conversion of fractions into percentages. As we have discussed in case of speed maths, fractions can be converted to percentages or percentages again can be converted to fractions. So if we are able to convert the fractions into percentages, then as per the percentages, they can be arranged in ascending or descending order. For example, let's say we have two fractions like 4 by 9 and 5 by 11. Now, from the knowledge of conversion of fractions to percentages, we know that 4 by 9 is 44.44% and 5 by 11 would be 45.45%. So if we are able to quickly convert the given fraction into percentages, we can decide which is a greater fraction. Because 45.45 is more than 44.44, we can say that 5 by 11 is more than 4 by 9. But friends, again, here if you look at these fractions, converting them into percentages would be a little difficult. But because the denominators are all again typical ones, 17, 23, 21 and 19. So friends, the best way to compare these fractions would be to convert them in terms of decimals and then compare the decimal answers. That is nothing but we need to divide 9 by 17 in the regular procedure. Similarly, 7 by 23, 11 by 21 and 13 by 19. And whatever answers we get can be arranged in ascending or descending order as per the requirement. For example, 17 has to divide 9. So we can say that this is 0 point. It can be taken as 90. Why? Because we have taken a decimal. And 17 into 5 is 85. So 5 is remaining. Again, when we take 0 here, because of one decimal already present, 17 into 2 is 34. So 16 will be left out. 16 approximately is 1 time. So we can say that the answer approximately for 9 by 17 is 0.52. Similarly, 7 by 23 can be divided and the answer can be taken in terms of decimal. What we need to do here is take at least up to 2 decimal places. So 7 when divided by 23, we get this as, if we take 0 point, this becomes 70. Now 23 into 3 is 69. So 1 is remaining. So this can be taken as 0.3, approximately 0.3. Similarly, let us find out what is the value of 11 by 21. So 21 when divides 11, we can take 0 point here and this becomes 110. So 21 into 5 is 105 and the remainder is 5. Again 0 can be taken here. 21 into 2 is 42. Remainder is 8. Now approximately 11 by 21 can be taken as 0.52. But now if you try to observe, the first fraction 9 by 17 is 0.52 approximately, and even the third fraction 11 by 21 is approximately 0.52. That means here we need to proceed for the third decimal place so that we can compare them. Or otherwise these two fractions can be cross multiplied and we can find out which is greater of them. But let us go by the decimal here. So if we try to observe 11 when divided by 21, the remainder was 8. So if we go for the next step, we know that 8 is a very small part of 21. Whereas in case of 9 by 17, we found that the remainder was 16 and 16 is almost equal to 17. So definitely this is a larger value when compared to 11 by 21. So we can say that this is 0.52 or approximately 0.53. Why? Because the remainder here is 16. So if we take a 0, 17 almost 9 times will be equal to 153. So this is 0.529, which brings it very close to 0.53. Whereas in this case, it will be not as close as to 0.53 as compared to this fraction. So we can understand that 9 by 17 is greater than 11 by 21. And finally, again 13 by 19 can be divided. The answer there would be approximately 0.68. So if we try to arrange these fractions now, we find that the smallest fraction is 7 by 23. The next one here is 11 by 21. The third one here is 9 by 17 and the fourth one is 13 by 19. So this is the ascending order or nothing but the increasing order of the given fractions. So what we have understood from this example here is multiple ways are there in which the given fractions can be compared and the ascending or descending order can be obtained. It all depends on the type of fractions given to us. If the fractions are complicated as in this example, we simply go for division and get the answers in decimals and arrange them accordingly. Otherwise, we can follow cross multiplication, or we can go for LCM, or we can go for percentages conversion to compare the given fractions. So you have to decide which method is the best for the given question and apply that one accordingly. That's all from this topic of number systems. Practice well on these questions. See you in the next session. Thank you.